we got to talk about period, domain, and range, and all that junk. So our period for this function, a quick reminder about the spots period shows up as 2 pi over whatever our b value is. In this case, our b value rather is always right next to the x. But it needs this extra bonus pair of parentheses around there. If it's not there, you need to add them. You can't just willy-nilly add them. We need to then divide out that 3 that we took out from that parentheses. Imagine if that 3 was distributed back in, turn right back into pi. In terms of our period, it doesn't really change. 2 pi over b, which is 2 pi over 3. So that's how long it's going to take for our graph to complete one of its loops. The domain of this function is how far what things work for it. Cosecant has certain spots where it's freaking out. We're going to take care of it. We're going to spot that on the graph. We also care about its range, where it's good. We'll spot that on the graph. I think making this graph is going to make our lives a lot easier. So let's do it. Let's graph this thing. I would like to actually do this one on Desmos. Give me a minute while I set that up. Okay, so I've got this all set up in Desmos. Now I did a little work just to make sure it looks nice. So here's our graph. Desmos does understand cosecant. Your graphing calculator doesn't have a button for it, so you just type 1 over sign instead of cosecant, and then you type all the stuff that goes inside of it. Now, quick reminder about how we graph these things. We did graph these in pre-calculus, but the way we graph them is we actually graph just regular sine. So we would graph sine using all these tricks. We would first take care of our period. That was the first thing we graphed. We went 1, 2, 3, 4. And we wrote our period, which was 2 pi over 3. Then we would need to move up 2 because we have this plus 2. So here's our start point. It needs to move pi to the left, so it kind of goes back this way. So here you can see it's kind of sliding to the backish. That's why it's going down first instead of up. Sine's supposed to go up. So really this thing is starting back here as your first initial point, and then we would wobble from there. But I'm just keeping it positive just because it's easier to look at. And then we're changing how high and low it goes. It goes down 3 and it goes up 3 based on our amplitude right here of 3. Then, once we have done all of that stuff, then we would say, okay, well, by all of that, and we need to say, okay, well, I want cosecant. And what cosecant does is it bounces off of the tops of sine. If we had secant, secant would bounce off the tops of cosine. Tangent is weird and crazy, and cotangent. So this is our actual graph of cosecant. It's all of these parabolas that are bouncing away from each other off of the tops of sine. So back to that thing we were talking about earlier about domain and range. So range is really easy. I'm going to take care of that first. We can see our range pretty simply. So it starts down here, goes to -1, big old gap, get to 5, and we continue on. So for our range, so we go from -infinity to -1, bracket, because we reach the top of those parabolas. Then we get a u, another bracket, we start again at 5, and we go to infinity. Domain's a little bit worse. Domain is looking at, it seems to be everything. Everything seems to be fine, but there were a bunch of gaps. Every place that sine touches the sinusoidal axis, cosecant freaks out, because at this point, in a sense, sine becomes 0, and it's in the denominator. When you put a 0 in the denominator, everything freaks out. So whenever it's touching this 2 spot right here, cosecant is freaking out, and it doesn't exist. So we have to skip all of those spots. Fortunately, they're pretty easy to spot. Take a look. There's one right here. There's another one here, another one here, another one here, and another one here. It's at all the pi over 3s. So we just got to find a way to write that. So it's all real numbers. So here, I'm gonna cheat. I'm gonna use the R. So just big ol' R, except X cannot equal, we need all of the pi over 3's. So we need pi over 3, we need 2 pi over 3, we need 3 pi over 3, we need 4 pi over 3, we need 5 pi over 3. So we just need n pi over 3's. We can put plus or minus in front of that too. So that is our domain, and that is our range. And I've already drawn the graph. That was on the other doodad. So important things that I want you to get out of today. I don't really care about the graphs that much. What I do care about is you remembering your golden nugget. Make sure that you remember how to do these trig functions, how you can calculate these trig functions. Graphing is less of a big deal, and that's especially why I'm just kind of hand waving my way through it. It's more just forcing you to think more about the trig functions. But if you know how to do your oral exam, that is going to be the big thing that's going to be helping you out, I feel, for calculus. So make sure that you really have this golden nugget living in your head. All right. So thanks. Have a good day.